Hey guys, so thought I'd do some solutions for the half-yearly exam. So well done for clicking on this video and checking it out. It's going to really help you. So the how to learn habits, especially that we're looking at, you guys are capitalizing on this resource. You're revising, remembering and making links. Hopefully you're distilling what we're doing here, so getting those key points. And you're being accountable for your learning, which is fantastic. And hopefully you've got some headphones in and you'll be able to listen effectively. So the video is just going to be, I'll just go through the solutions and then we'll talk about where you can go next. Okay. So your learning intentions. Well, like I said in class, I want you guys to be able to move your mark for the half yearly exam up to 80%. So that 80% mark is going to tell us that, yep, you've got a good understanding of what we did in the first half of the year. Okay, so let's get into it. So simplify the following expression. Okay, so here we're looking at fractions, but we've also got some algebra. Okay, so it makes things a little bit more complicated. At the moment, we need to check when we're adding fractions, we need to check the denominator is the same. Okay, so this is going to check that the fractions are the same type. Okay, so if I had 1/4 plus 2/4, I get 3/4, okay? And I can do that because the fractions are the same type. So we're going to apply the same thing here. We've got 2a on 4 plus 8a on 4, so we're going to end up with 2a plus 8a over 4, okay? And that's going to give us 10a on 4, and that was 1 mark, okay? Before I do question 2, I'll just have a look at question 3. So when we're multiplying fractions, this is one of the easier ones, okay? We don't have to do any checks. We can just multiply the top 2. So we're going to multiply these guys and multiply the bottom 2. After that, we may have to do some simplifying, but the process is probably the simplest. Okay, so 2ab times 6 on top, and on the bottom we've got 3 times 2b. All right, so let's take a look at that top one. Well, 2 times 6 is going to give me 12 AB, and 3 times 2B is going to give me 6B. Okay, so like I said, we might have to do some simplifying, and we will here. So the 6 goes into the 12 twice, so that's going to cancel, and we're going to be left with 2. All right, and B divided by B, so B over B is going to cancel, and that's just going to leave, well, what have we got on top? Well, we've got 2 and A. So our final answer is 2A. Okay, so let's go back to question 2. When we're dividing fractions, we need to change it into a multiplication. Okay, and we need to flip the second one. Okay, now if you want a more detailed explanation of why we have to do that, come and see me. Okay, I'm not going to go into that in this video. So let's do that. So we've got 9a squared on b over 5, and we're going to make that a times, flipping this second fraction, so we get b squared on 4. Okay, now we've got a multiplication problem, and we can just, like I said before, multiply the top 2, so we get 9a squared b times b squared over 20. Okay, so let's take a look up at the top here. We've got b times b squared. Now, a lot of things in mathematics are invisible, okay, and this is another case where we've actually got a 1 there, so that's b to the power of 1. Okay, now when we're multiplying two things that have the same base, we can just add the indices. Okay, so let's ignore that 9a squared part, that's not changing, so we've got 9a squared, we've got b to the power of 1 times b to the power of 2. So when we add the indices, we get b to the power of 3 on 20. Now, can we simplify that any further? No, I don't think so. Okay, there's no common numbers for 9 and 20, so we can't simplify that one any further, and that's done. Let's go to question 4. So up the top here, when we were adding, we needed to make sure the denominators were the same. Okay, and we do the same thing down the bottom when we're subtracting. Okay, so I need to make these the same here. So this part on the bottom and this part on the bottom. So how am I going to do that? All right, well, I've got to multiply this left-hand fraction by 2. Okay, now if I've multiplied the bottom part of the fraction by 2, I also need to do that to the top. Okay, so that's keeping the fraction the same. Otherwise, if we just multiplied the bottom part, we wouldn't get the same fraction. Okay, so now what we've got is 6 on 2x, take away 1 on 2x. All right, now the denominators are the same, so we can just take away the top 2. Okay, so 6 take away 1 gives me 5 on 2x. And this was a 2-mark question. Okay, and that's because you had to, like, there was a bit of extra work to do, so we had to remember to change that first fraction. All right, so stop, like pause the video and have a look if you want to go back over any of these. Otherwise, we'll move on to question 5 to 8. Okay, so we had to expand the following expression. So I've got minus 3 lots of x plus 5. Okay, so we need to do minus 3 times the x plus minus 3 times 5. Okay, so minus 3 times x gives me minus 3x plus minus 3 times 5, and that's going to give me minus 15. Okay, so obviously we're not going to leave our final answer like that. We need to sort out this mess in the middle here. So if I've got a plus and a minus, that's going to become a minus. Okay, so I've got minus 3x minus 15. If it was a minus and a minus, we'd have a plus. A plus and a plus would obviously have a plus as well. So hopefully you guys remember those rules. All right, so for this one, we've got a bit more to do now. So we have to expand and then simplify the following expression. So let's repeat that process here. So we've got 2y times y gives me 2y squared. 2y times minus 5 gives me minus 10y. Now you see, I sort of skipped a step there. So instead of writing the minus and then doing that, I just combine them there. So moving on to the next part, we've got plus 4 times y and 4 times minus 5. So 4 times y gives me 4y, and 4 times minus 5 gives me minus 20. All right, so here's where we need to look at whether we've got any like terms. Okay, so like terms are when we've got the same variable raised to the same power. Okay, so we've got y to the power of 2 here, and that doesn't look like we've got any like terms for that, but we do have 2 y's to the power of 1. Remember, when there's no number there, it's a 1, so we can combine these two. Okay, now they might not always be next to each other, so be aware of that. So minus 10y plus 4y, well, if I'm at minus 10, whoops, I might undo that. Sorry, hang on a sec. There we go. If I've got, oops, excuse me, still learning how to use this tablet. All right, so let's try again. If I'm at minus 10y and I have to add 4y, I'm going to be back at minus 6y, and here's 0 somewhere up here. Okay, so our final answer is going to be 2y squared minus 6y minus 20. All right. Keyword for question 7 is fully factorise. Okay, so we've got, how do we do that? Well, we need to see, is there a common number? Okay, so is there a common number for these two terms? So we're going to look at each term individually. Okay, yep, so 3 is going to be a common number for those terms. Just looking at the numbers there, not worrying about the variables for now. Now we say, all right, is there a common variable? Okay, so x squared, and we've got x, so x is our common variable. Okay, so we put our common term out the front, and now we put down our brackets. So let's think about what's going to go in this position here. So 3x times what is going to give me 3x squared? Okay, so we know that that's going to be 3x times x. Okay, so if we multiply that out, we get 3x squared. And now I've got to add 3x times what gives me 9x. Okay, 3x times 3 would give me 9x. Okay, so you can check your answer when you factorize. If you expanded that again, you should get back to your original expression. Okay, so fully factorizing the following expression again. So common number, so 2 is our common number. 2 goes into 2 and it goes into 10, just like 3 went into 3 and 3 went into 9. Okay, so we call that the highest common factor. All right, now let's look at the variables. So what's a common variable here? Well, we've got y. So 2y is our common term. All right, so let's think about what we've got to times that by. So 2y times 1 gives me 2y, and 2y times minus 5y would give me minus 10y squared. Okay, so again, how can I check? Well, if I expand that, I need to get back to my original expression here. All right, let's keep going. So 9 to 10. So this square, keep in mind we've got a square, concrete slab below 20 centimeters high and side length of 3.3 meters. Calculate the surface area. So we've got to find what is the total area of all the surfaces on this concrete slab. Okay, so this top one, well, it's a square. Okay, so it's going to be 3.3 times 3.3. All right, now to make things easier, well, let's put that in brackets and times it by 2. And that's going to take care of the bottom square as well. Okay, so what have we got to add to that? Well, we've got these parts here. So there's 4 of them. All right, and they are 20 centimeters high. So how do I write that in meters? All right, 20 centimeters in meters would be 0.2. And how long are they? Well, they're 3.3 meters. Okay, so we've got 4 lots of 0.2 times 3.3. Okay, so you could put that in your calculator and get your final answer there. All right, so let's have a look at question 10. All right, now I haven't got a calculator with me, so I'm going to leave these calculations for you, and you should be able to follow along with your calculator and get the right answers. So given 1 cubic meter of concrete weighs 2,400 kilos, calculate how much the slab from question 9 weighs. All right, so a lot of people sort of try to use their answer for surface area on this one, and the surface area has nothing to do with it. We need to figure out the volume of the slab first, and then if we get that in cubic meters, we'll be able to times it by 2,400 to figure out the total weight. Okay, so given 1 cubic meter of concrete weighs 2,400, how much does it weigh? So let's go with the volume. So the volume of a prism is equal to the area of its base times its height. Okay, so the area of its base, well, this up here, this is its base. So this square shape up here is its base. So that's going to be 3.3 times 3.3. All right, and then we've got to multiply that by its height. And we're not going to multiply it by 20 because then you're using different units, okay? So it's not 20, it would be 0.2. And that way these are all in meters and we're not going to have any issues. Okay, so that'll give you its volume in cubic meters. All right, and are we done? Well, no, we've got one more thing to do. So we've got to times how many cubic meters it is by 2,400, because 1 cubic meter is 2,400 kilos. And that would give you your final answer. All right, so let's keep going. So this question we had to just give definitions for each variable. So FV is our future value. PV is our present value. R is our rate. N is the number of terms. Yeah, so if we're trying to figure out a value that's occurring in the future, future value is going to be what we need to find. If we're trying to figure out how much someone needs now in the present, present value is going to be what we need to find. And before I move on, rate and number of terms need to be in the same frequency. Okay, so if you've got a yearly interest rate, well, you need your number of terms to be in years. If you've got a monthly interest rate, you need the number of terms to be in months. Okay, so question 12, convert the following percentages to decimal form. So a percentage is a fraction out of 100. Okay, and well, if I want to change that to a decimal, I'm going to do 25 divided by 100. And that will give me 0.25. So 1% is 1 out of 100. That would be 0.01. 13.4% out of 100. That would give me 0.134. Okay, question 13. The standard deck of 52 cards is shuffled and the top card is drawn. What is the probability that the card is a club or, so keeping in mind how this question is worded, or a king? Okay, so how many clubs are we going to have in the deck? Well, we're going to have a quarter, because there's 4 suits and a club is 1 suit. A quarter of 52 will be clubs, so that's 13. All right, now keep in mind that one of those 13 cards is a king. Okay, we've got a king of clubs. So how many other kings are there? Well, we've got the king of spades, the king of hearts, and the king of diamonds. So we've got to add 3. All right, so we get, well, there's 16 favorable outcomes out of 52 outcomes altogether. Okay, question 14. A sports bag contains 3 cricket balls, 5 tennis balls, and 4 golf balls. If we pick one at random, what's the probability that it is not, again, so paying attention to how the questions are worded, that it is not white? All right, so how many balls are not white? Well, we've got 3 red cricket balls and 5 yellow tennis balls. So that's 8 out of, how many balls do we have all together? 8 out of 12. Okay, so you could have simplified that further and said 2 out of 3, but I'm pretty sure I would have given the mark for 8 out of 12. All right, so another definition. So we've got the surface area of a cylinder. So changing our context here, okay? So before R stood for rate, this time, because we're looking at a cylinder, hopefully you picked up, well, that's going to mean radius of cylinder. Okay, H is going to be the height of the cylinder, and SA stands for the surface area. So these questions were 2 marks, and if you got all of them right, you got the 2 marks. If you got a couple of them right, you might have got 1 mark. Even 1 right might have got 1 mark. I'm not exactly sure on how I marked it, but that's the general gist. Okay, so find the volume of the following prism. Okay, why is this a prism? Well, if we cut it in half, if we sliced it like this, we would get exactly the same shape. Obviously, you would be drawing this a little better, but we get the same shape. So that's what makes a prism a prism. All right, so how are we going to find the volume? Well, we had a question like this already. So the volume of a prism is equal to the area of its base times its height. Now, in this case, the height, and this is a variable you really have to be careful of, height. It's not always referring to the up and down height. Okay, and in fact, you're not given that in this question. All right, so keep in mind, sometimes the height is referring to this part here. So how can you remember? Well, you're going to have to practice. Okay, so practice picking up on what unit to use for the height. Okay, so the area of the base, well, if I just get rid of this. Okay, so the area of the base is given, it's 15.5. All right, and we've got to multiply that by the height, which is 6. Okay, so what's that? That's going to be 93 centimeters, and we're dealing in volume, so it's going to be cubed. Okay, so let's keep going. 17. All All right, so Scott's parents deposited $1,000 in a savings account for him when he was born. Given the interest rate was 3.5% compounded yearly, calculate the future value of the account after 18 years. Okay, so future value is what we want to find. Now, I just remembered I do have a virtual calculator, so I might bring that up. Just give me a second to do that. Hang on a sec. Keep. No, okay, it's not there. It must be my desktop. Here we go. All right, so let's see if we can use that. All right, cool. So we've got Scott's parents. They put $1,000 away when he's born, thinking he'll have a nice 18th present when he gets there. So when we're using a formula, first thing you need to do is write it down. Okay, so FV equals PV 1 plus R to the n. Okay, now this formula was written earlier in the test. Okay, so we want to find, we don't know what FV is, we want to find that. So its present value was 1,000. 1 plus, now the rate needs to go in as a decimal. And it's happening over 18 years. Okay, now the rate, you could also write that as a fraction. And remember with percentages, it's how you like to do it, okay? So if you remember it a particular way, do it that way. All right, so let's calculate that. So we've got, let's do the inside part of the brackets first. Actually, we might be able to type it in. So 1,000 times, open bracket, 1 plus 0.035. We're raising that to the power of 18 equals. All right, there's our final answer. So 1857, let's see, I wonder if I'll be able to write at the same time. Nope, okay, hang on a sec. 1857, 489196, so 0.489196. Now, dealing with money, okay, so that means to the nearest cent, which is 2 decimal places. Okay, so we've got to check this one. Remember, if that's greater than or equal to 5, we have to round up. Okay, so we're going to have to add 1 to this column here. All right, so our final answer is going to be 1857.49. Okay, so he'll have a nice little 18th there. Okay, part B, a local sporting organisation will need $20,000 to recarpet and paint their new clubhouse in 10 years' time. Okay, so this is what you might get involved in when you guys get older and get involved in sports organisations or any other committees and things around town, is future planning. Okay, so they've got a new clubhouse. They know that it's going to need some maintenance, and carpet is a big one. Okay, so they're going to say, right, well, let's make sure we've got 20 grand in 10 years to put the new carpets down. Okay, so we're trying to find the present value. So what do they need to put away today to have the 20 grand in 10 years? Okay, so looking back at our formula up here, we're trying to find present value. Okay, what is the future value? Well, actually, let's do things properly. So let's write our formula out. Oops. 1 plus R to the end. Okay, so future value is 20 grand. That's what they want in the future. Present value, we don't know. Okay, we're going to work that out for them. Now the rate is, and I'll do it differently this time, we'll put it in as a fraction, 4.8 over 100. And this is occurring in 10 years. Okay, so there our key points are in that text. All right, so let's calculate that. Well, I want to find out what PV is, so I need to get it by itself. Okay, now currently it's linked to this huge thing by a multiplication. So what's the opposite of multiplying? Well, we can divide. If we divide this side of the equation by that, that's going to cancel out. But what we do to one side, we have to do to the other. All right, so these are going to cancel out. And what are we left with? Well, I'm just going to move the PV over to the left-hand side. PV equals 20,000 over 1 plus 4.8 on 100 to the power of 10. So let's pull our calculator out to do that. So clearing that, we've got, right, so I'm going to show you guys how you can do this in one step. 20,000, whoops, too many there. 20,000 over bracket 1 plus, I need another fraction, 4.8 over 100. Whoops. Nope. I want to go out of that. And that's all raised to the power of 10. Okay, so that's the great thing about these calculators, and why you need to get one if you don't have one, is you can type in what you see on your page in your calculator. All right, and that's telling us they need $12,514.61. So 12,514.61. 12,514.61. Okay, so 2-mark question there. A student purchased a new laptop computer for $2,000 before starting uni. Given the laptop depreciated at a rate of 25% per annum, calculate the value of the laptop after 3 years. So after 3 years is telling us, well, hey, we want to find the value of something in the future. Okay, so here's my formula. Now, depreciated means dropped in value. Okay, so what we actually need to do here is change this one to a minus. Okay, so we can just modify that formula slightly so that it's depreciating instead of appreciating. Okay, so your savings accounts, you know, they're all going up in value. Sometimes we want to figure out how much something goes down in value. Okay, and that's especially useful for tax purposes. So present value, well, what does it cost? What is it worth today? It's worth $2,000. All right, 1 minus the rate. So shocking rate here, 25%. Okay, I put that one in as a decimal this time, and it's happening over 3 years. Okay, so let's use our calculator again. Clear that. So we've got 2,000 times 1 minus 0.25 all to the power of 3. Now, what happens here? Well, that's not helpful. I don't want to know how many quarters this thing's worth. I want to know how many dollars it's worth. So I'm going to press SD, so that button just above delete there, changes it back to decimal. 843.75. So 843.75. So it dropped in what, a bit over $1,150 in the 3 years. Now, if you're a student, that's probably going to be tax deductible. All right, 18, nearly there. So Frank takes out a coin and challenges Joe to guess the result of 2 coin tosses. Draw a probability tree to represent the situation described. So probability trees are horizontal. I saw a lot of nice vertical ones in the exam, but they are horizontal. And we've got, for this particular experiment, we've got 2 outcomes. So we've got a head or a tail. Okay, so that's the result of the first toss. Okay, what about the second toss? Well, same thing. We've got a head and a tail, a head and a tail. And this is going to be our second toss. All right, and that's all you had to do. Joe guesses there will be a head followed by a tail using your probability tree or otherwise. So you may, like if you didn't get the probability tree, there are other ways to do this. Determine the probability that Joe will not be correct. So he's guessing that it's going to be a head. So we're going up this way, followed by a tail. Okay, so that's Joe's guess. Well, what are the chances of that guess happening? Well, that's this one out of 4. Okay, so there's an outcome, there's an outcome, there's an outcome, there's an outcome. Okay, so this is head, 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 tail, tail, head, tail, tail. All right, so Joe's guessing this one. So that's 1 out of 4. He's got a 1 in 4 chance of being right. The question's asking us, what is the probability that he will not be correct? Okay, so that's when we're going to count up these other ones. So we've got 1, 2, 3 out of 4. Okay, explain why the statement below is incorrect. If you obtain a tail on 4 consecutive coin tosses, now remember consecutive means one after the other, in case you weren't sure of that, one after the other. Just make that look like a 1. So what you have a higher chance of obtaining a head on the next coin toss. Okay, so hopefully you guys picked up that this isn't true. Okay, tossing a coin is an independent event, and the results of previous tosses will not affect the next toss. Okay, so if you gave a statement along those lines, you would have got the mark there. So you had to explain why. All right, 19, which I think is our last question. So a manufacturing company produces semicircular shelters like the one pictured below. The width of the shelter is 8 meters and it's 12 meters in length. Calculate the external surface area of the shelter. So again, we had this this surface area of a cylinder formula previously listed in the paper. Okay, and I think it was SA equals 2 pi r squared plus pi r h. Pretty sure? Yep. No, 2 pi r h, sorry. 2 pi r h. All right, so we've given that formula. Now that's going to find the surface area of a full cylinder. Okay, we're just looking for this semicircular shelter here. Okay, so let's pencil these measurements in. So it's 12 meters long and it's 8 meters wide. Okay, so hopefully you guys picked up, well, that means it's got a radius of 4. Okay, radius is half the width or half the diameter. Now, which parts of this formula are we going to use? Well, it hasn't got any ends. Okay, so this 2 pi r squared part, if we look at a normal cylinder, as normal as I can draw one, the 2 pi r squared part is these circular bits on the end. So we've got 2 lots of pi r squared. Okay, so we're not actually going to use that part. Now the 2 pi r h part, that's what we're going to use. So that's going to find the curved surface area, so the area of this part. Okay, so let's use that. So we've got 2 times pi times, the radius is 4 and the height is 12. Okay, so we'll get an answer for that. What are we going to do with that answer? Well, that's the surface area of the whole cylinder's curved part. Okay, we're only looking for that semicircular part. So we're going to divide that answer by 2. Okay, now 2 divided by 2 is 1. So that cancels out. So we could find our final answer by going pi times 4 times 12. Now, in future mathematics courses, you might be asked to leave your answer in exact form. And what that means is, instead of evaluating what pi is and getting some decimal value, you could just leave your answer like this. So 48 lots of pi. Okay, so that is exact form. All right, but we'll do the decimal one today. So let's get our calculator out again. Clear that. So 48 times shift pi equals. All right. Calculator's telling us 48 pi. I want to change that to a decimal. Okay, so 150.796. 150.796. and that's in area, so we're in meters squared. All right, the canvas material used to cover the shelters is sold in rolls of width 3 meters. Calculate the length of material needed to cover the shelter. Okay, so if we've got 3 meter width, that's going to be 1, 2, 3, 4 lots. Okay, so we've got 4 lengths that are going to go along there. How far do they need to go to get over to here? So that's what we're going to have to work out. All right, so to do that, how far is this length? How can we work that out? Well, that's going to be half the circumference. Okay, and the circumference equals 2 pi r, or pi d. All right, we're going to use this first one. Now that's for the whole circle. I only want half the circle. Okay, so they're going to cancel. And we just need pi r. So pi times 4 is going to give me that length there. All right, so let's figure that out. 4 times pi, 4 pi, I want decimal, so 12.566. Now I'm just rounding to 3 decimal places. You might round to whatever. 3 decimal places is going to be accurate, but well, to be honest, I shouldn't have, because we're supposed to round on our final step. Okay, so I'm going to actually bring that up, 566.37061. So when you're rounding, if you round mid-question, that's going to introduce errors into your answers. Okay, so make sure you do your rounding at the final step. So that's how long it is, and we need 4 lots of that. Okay, so we're going to multiply that by 4. And our final answer is going to be 16 pi, yep, great. 50.2654, so 50.2654, 8246. And now we can do some rounding. So let's go to the nearest, well, it's a manufacturing company, so I'm sure they'd be able to cut it to the nearest millimeter, which is the nearest thousandth of a meter. Okay, so we're checking this 4th decimal place. This 8 is bigger than 5, so we have to round up. All right, so 50.2655 meters. That's how much material we need. All right, cool. So part C, last one. If it costs $73 per meter, calculate the cost of covering the shelter. So we've got $73 a meter, and we need 50.2655. So what are you going to do to figure out your final answer? Well, we need to multiply them. So let's go, we've already rounded, so we need to use this number, 50.2655, oops, times 73. So our cost, and I'm going to round that to 2 decimal places because we're dealing in money now. So our cost is 36.69.38. All right, great. So that concludes, oh, hang on. We've done that one, haven't we? Yeah, good. Follow up. Okay, so what do you need to do now? All right, well, like I said, we want everyone to get up to 80%. So have another go at the test, and just, you need to believe that with a bit of effort and a bit of work, you're going to be able to do that. Okay, so refer back to these solutions. It's not cheating. Okay, it's using the resources you have. Make sure you get up to 80%. So I think the test was out of 50. So see if you can get yourself a mark of 40. Now, for some people, that's not going to be too far. Other people, that's going to be a fair way. And it'll take them a little bit longer. I'm always available. During the holidays, you can email me. I'll put my email down, edward.wilson, whoops, can't even spell my name, fantastic. All right, Wilson6 at det.nsw.edu.au. So email me on that if you want any further explanation of anything. I might be able to do a video solution for you and send that back to you. And keep an eye on the Moodle. I'll try and put some stuff up on there. One more thing to mention, I've set you all up on Khan Academy, and I did email you this document. So it just looks like the exam, but if you scroll down, all right, if you scroll down to here, you can see these green boxes. All right, so I emailed you this document and everyone received it. When you open it in Chrome or your internet browser, these green boxes aren't going to come up. Okay, I'm not sure why that happened, but that's just how it is. So what you need to do is save it to your USB or to your school drive or your Google Drive, wherever you're saving it, and open it with Adobe. Okay, so with Adobe Reader or Adobe Acrobat. And if you open it with that, these features are enabled. Okay, so why am I talking about these features? Well, these green boxes, so this box covers this 4 questions, all right? And what it is a link to the Khan Academy page, which is going to help you solve those questions, okay? So if I click on this one, here's the page on combining like terms, all right? If I click on, well, let's go down a bit. Say I wanted to click on this one, there's the page on compound interest. All right, so please take advantage of this. And if you didn't, if something didn't quite make sense in the video solutions I put up, you can always have a look at Khan Academy. Okay, so that would be someone else's perspective, which might make a bit more sense to you, and it might be a bit more detailed as well. Okay, so take advantage of that, and yeah, stay positive.